remember, the actin is the blue filament that you see here. The myosin is the red. It is a protein, contains ATPase. Remember, when you see the these ACE at the end of a word, it's letting you know it's an enzyme, which will split the ATP to generate power for muscle contraction. Now keep in mind, adenosine triphosphate, or ATP, is a high energy bond. When a phosphate breaks free, energy is released. Okay, now the video will show that. Some of those videos will show that that chemical breakdown through an animation. The thick filament is the length of the dark A band. So here's the thick filament. And then the myosin will contain these myosin heads, and their job is to bind to actin. Actin, or the thin filament, is a contractile protein, and also will aid in the preventing of contraction of the heads of the myosin. Now, that may sound a little confusing, but keep in mind that the myosin heads should not bind to actin unless acted upon. Okay? Otherwise you get weird muscle contractions and things that are abnormal. Okay, now the video, if you watch it, will show you how the myosin heads bind to actin and create the sliding filament. So yes, at some point the myosin head will bind to actin at the binding site, but once it releases and the contraction is over, you don't want it to continue to bind. So there is a preventing mechanism, and that gets into the troponin tropomyosin complex, which the video will show that as well. So when a contraction occurs, the actin filaments slide toward each other, toward the center of the sarcomere. The bare zone, which is that H zone, so let's go back right here. Here's the bare zone. That will disappear because the actin and myosin are completely overlapped. This is the actual slide of the filaments. Okay, the sarcoplasmic reticulum, which is the purple sleeve that you're seeing there, its function is to store and release calcium. That is a very important concept and process that our bodies and our muscles need, to store and release calcium when the muscle fiber is stimulated to contract. Of course, that is your neurological stimulation, or the action potential. When that nerve signal comes in, it starts a cascade of events. One of them is to get the sarcoplasmic reticulum to release its stored calcium. So an electrical signal comes in and hits the myofilaments. ATP, which supplies the energy, a phosphate is broken off, calcium is released, all this binding is now allowed to take place, and you get a disappearance of the bare zone. The filaments slide toward each other and you get muscle contraction. The video does an excellent job showing you this, and I've posted several of them, so make sure you take a moment and watch them. Okay, once the contraction is over, calcium is absorbed back into the sarcoplasmic reticulum storage areas. That's what the SR means, is that's short for sarcoplasmic reticulum. The muscle relaxes, goes back to its original length, and then there's that refractory period, and then it can happen again, a muscle contraction. Okay, here's the actin part, and there's the myosin part, and you're seeing the myosin heads binding to actin. In the presence of calcium, you start to get actual movement. Okay, the troponin tropomyosin aid in the unnecessary contraction because they will cover up the binding sites on the actin. So an unnecessary myosin head binding does not take place. Okay, here's the troponin tropomyosin complex. Just showing you a picture of what that looks like, where you actually have the troponin, which is that yellow that they're showing there, and the tropomyosin is that band. And this part is just breaking down from beginning to end, your axon terminal, a signal coming in.